Okay, so for what feels like forever, one single architecture has absolutely dominated AI, right? I'm talking about the transformer. It's the powerhouse behind basically every big breakthrough you've heard about. But what if that's all about to change? There's a new player on the scene. It's called Mamba, and its whole approach is fundamentally different and, maybe a whole lot more efficient.
So to really get what makes Mamba such a big deal, we're going to walk through the whole story. First, we'll dig into the Transformer's hidden weakness, the problem Mamba was born to solve. Then, we'll look at a kind of clunky, earlier attempt to fix it. After that, we'll get to Mamba's superpower, its selectivity. We'll even uncover the clever trick that keeps it so fast. And finally, we'll tackle the big one. Are we looking at the new king of AI?
All right, let's kick things off with Section 1. To really appreciate what Mamba brings to the table, we first have to talk about the OG, the Transformer, and the one major flaw it's been hiding.
So yeah, like we said, the Transformer is pretty much the engine running all of modern AI. We're talking everything from LLMs to those wild AI image generators. And at its heart is this one key piece of tech called the attention mechanism. That's the secret sauce that lets these models really understand context and do all the incredible stuff they do.
But, there's always a catch, right? This amazing power comes with a pretty hefty price tag. We're talking a serious computational bottleneck that's holding us back from scaling these models even further. So what is this hidden cost?
Well, the problem has a name. It's called quadratic scaling. And here's the best way to think about it. For every new word, or token, that a transformer reads, its attention mechanism has to look back and compare to every single word that came before it. So as you make your text longer, the number of these comparisons it explodes. It doesn't just grow, it grows exponentially.
And here's what that looks like in the real world. If you double the length of a sentence you feed the model, you don't double the work. Nope, you quadruple it. That's O of n squared complexity for the technically minded. And honestly, it's a total scaling nightmare. It makes it ridiculously expensive and slow to process really long things like, say, an entire book or a complex genome sequence or even just a long audio file. So this wasn't exactly a secret, right? Researchers knew this was a huge problem. And that brings us right to our next section, the hunt for a better, more efficient way to do things, long before Mamba ever entered the picture.
One of the big ideas researchers were playing with was a type of model called a state space model, or SSM for short. And on paper, these looked amazing. They process information linearly, which means they're super fast and efficient, but they had this one fatal flaw. They were time invariant. Basically, that means they use the same rigid, unchanging rules for every single piece of data they saw. And when you're dealing with something as messy and nuanced as human language, well, that just doesn't fly.
And this really gets to the heart of the problem. On one side, you've got these older LTI models. They're fast, sure, but they have this one-size-fits-all approach. They treat every single word exactly the same. They just can't tell the difference between a super important keyword and a simple filler word like and or the. What everyone wanted, the Holy Grail, was a model that could be smart about it, something that could intelligently focus on the important stuff and just filter out all the noise.
And that is exactly where Mamba comes in. This brings us right to its core superpower, the big idea that changes everything. The creators call it selectivity. This is where things get really interesting.
The authors of the Mamba paper, Gu and Dao, just nailed it with this quote. They said, "We identify that a key weakness of such models is their inability to perform content-based reasoning." What they're saying is, they figured out that to be both fast and smart, a model can't just blindly chug through data. It has to actually understand what it's looking at.
Probably the easiest way to picture this is to think about how you read. You don't give every single word the same amount of attention, right? Mamba works kind of like that. It scans along, and when it sees a really important word, it slows down, it pays attention, it locks that information away. But when it sees a filler word, it just kind of skims past it, keeping its memory free for the stuff that actually matters.
So how does it do this? Well, here's the magic trick. Mamba's internal wiring, its parameters, literally change depending on the word it's looking at in that exact moment. It's content aware. This gives it the power to decide right there on the fly, okay, this is important, I need to remember this, or nope, this is junk, let's forget it and move on.
And this isn't just some cool theory, it actually works. This ability lets Mamba crush a test called the selective copying task. Think of it like a memory game where you have to remember a few key details hidden in a sea of distractions. Mamba aces it. Those older, efficient models, they just couldn't do it. They failed completely.
Okay, but wait a second.
You might be thinking, if the model is constantly changing its own rules for every single word, shouldn't that be super slow? I mean, how do you get that kind of smarts without grinding the whole thing to a halt? Well, that's the million-dollar question, and it leads us right into Section 4, where we find the real magic behind Mamba.
This is where the engineering is just brilliant. The creators of Mamba built what's called a hardware-aware algorithm. Basically, they designed it from the ground up to perfectly match how modern GPUs work. They pulled off a few amazing tricks. First, there's kernel fusion. Think of this like doing all your grocery shopping in one trip, instead of going back to the store for every single item. It saves a ton of time going back and forth to the GPU's memory. Then they have something called a parallel scan, which is a super clever way to take a process that looks like it has to be done one step at a time and somehow make it run all at once. And finally, they use recomputation. This is like deciding not to store the answer to a math problem, because you know it's faster to just recalculate it when you need it than to go look it up. I mean, it is just built for speed, right down to the silicon.
So, the theory is fantastic, right? It all sounds great, but at the end of the day, what really matters is, does it actually work? Well, that brings us to our final section, because the proof, as they say, is in the performance.
Let's talk numbers. In real-world use, when it comes to generating stuff, what we call inference, Mamba has up to 5 times the throughput of a transformer of the same size. 5 times! That is a gigantic leap in efficiency.
And get this, it's not just faster, it's actually smarter. Take a look at this chart. This is a language benchmark called the pile, and the stat we're looking at is perplexity. All you need to know is that lower is better. And you can see right there, Mamba's bar is lower. It's beating a super optimized transformer. And what's really crazy is the paper shows that the longer the text gets, the bigger Mamba's lead becomes.
But if you want a really jaw-dropping example, look at this. We're looking at a bunch of common-sense reasoning tasks. A Mamba model with only 3 billion parameters is outperforming a Pathia transformer that's more than double its size, 7 billion parameters. It is absolutely 100% punching above its weight class. It's doing more with less. And this isn't just a one-trick pony for language. No way. Mamba is setting new records, state-of-the-art performance in totally different fields. We're talking everything from genomics, like untangling super complex DNA sequences, all the way to generating raw audio. This really proves that it's not just a language model, it's a powerful, all-purpose tool for any kind of sequence data.
So, let's put it all together. You've got linear scaling that fixes the transformer's biggest problem. You've got better performance, even at a smaller size. And you've got ridiculously fast inference. When you add all that up, Mamba looks less like a competitor and more like a whole new backbone for the future of AI. So the question we have to ask isn't just, is Mamba good? It's, are we about to enter the Mamba era?